Hello learners, welcome to Education Online. I'm Madam Danny Susan, your teacher of math. Today we're still continuing with vectors, and here we're going to talk about magnitude of vectors. Magnitude simply means a length of a given vector. So in this case we're going to define magnitude, and we're going to have the different ways of how we find the length of a given magnitude. The word magnitude, which is the length, can also be the modulus of a given vector. So we are saying the magnitude of a column vector is its length. The magnitude of a column vector is its length. And the word length in this case can also mean magnitude is also the modulus. When you're asked to find the modulus, the length, the magnitude of a given vector, what we mean by is for you to find the length of that particular vector. So modulus, which is used to refer to a positive square root of a number. Square root of a number. For example, let us say let A be a point on a column vector. So we're going to have a drawing here. So we are having a point A with the column vector xy. Remember, it is magnitude, directions are always important. So we shall have a drawing like this. This is the movement of our vector. This is the origin. This is the direction which we are saying it is A. And this is point A where we shall have x and y. Then this is our x. And this is y. And this is point B. So with this we are saying, let A be a point. Let A be a point with column vector xy. This is the column vector x, y. The point where A meets, we are having the x and the y. This is the point where the two meet. So we are saying, using Pythagoras theory, we need to get the other direction, the value or the length. So we are saying, using Pythagoras theorem. Using Pythagoras theorem, we are now taking the sides according to the order. We are having OA, there is OB and AB. So we are saying OA squared should give us OB squared plus BA squared. So for us to get the value for OA, this is from A to B. If we talk, for example, talking of a displacement movement from O to A, we can move from O to B, then from B to A. That's what we mean by this. But in this case, we want to find the length OA. So for us to get the length OA, we need to have OB squared plus BA squared. So here we shall have our OA squared is equal to, our value of OB was x squared and the value of BA is y squared. We are squaring the values. OB was x. When you move from here up to here, we are saying that that distance is x, and when you move from B to point A, that distance is y. So with that, we are now going to have our OA. Remember, we want the value of OA. So for us to get rid of this square root sign, we are going to introduce square root on both sides so that we can get value of OA independently as the length. And as we said earlier on, that the length is a positive value of a square root number. So in this case, we are going to introduce square root sign on both sides. So we shall have OA squared, but you put a square root sign, is equal to, on the other side, we are going to have x squared plus y squared, but also under a root. In this case, we want the value of OA, so the square root sign will cancel with the with the 2, and we shall be left with OA is equal to square root of x squared plus y squared. So this is the formula that's going to help us to find the length or the modulus of any given vector. When asked to find any length of a number, first of all, you need to know what are the values of the two directions being asked for. Vector is simply the displacement. So if we are to find the distance of A to B, what are the shortest other routes that you will find you will take to reach B? Those are the distances we shall calculate to give us the length. So let's have an example. We are saying the magnitude can be denoted as, you write it as, remember we are given in the diagram I wrapped that our direction, which was the movement which was from O to A, we had this as our value there at A. So we are saying the magnitude of A, these two lines is to show us that the magnitude or the length. So the magnitude of A in this case should be the root of x squared and y squared. Let's have an example. Okay, let's first explain this, that A, magnitude of A is that this is the magnitude or the modulus of A. So this sign simply shows that it is the length, the magnitude or the modulus of A. Let's have an example. If AB is equal to 3, 4. If AB is equal to that, let's find the magnitude of AB. Let's find length AB. And we now know that the formula for finding the length is simply squaring the value of the x, like the distance, the movement in the x direction, which is the horizontal movement. You add it and also square the value for the movement in the vertical direction. So in this case, we are now going to say the magnitude of AB, or the length AB, should give us 3 squared plus 4 squared, but both of them under a root. So when we have this, 3 squared is the same as 9, and 4 squared is the same as 16, but all of them under a root. So we continue. When you add 4 and 9 and 16, you'll be in position to get 25. So we continue to say our length AB will finally be, the square root of 25 is 5. So we shall have our final answer as 5 units as required. Let's have the next example. We are saying that should be 1 if P is equal to 3, 1, then Q is equal to negative 1, 2, and R is equal to 4, 3. Find our A magnitude of P. Then part B is saying we find P plus Q but its length. Then C is saying we should find the magnitude of 3P minus 2Q. So let's have solution for these numbers. We are being asked to find the length of those given letters. But we need to first know the values of each of the letters being given. For example, P is 3, 1, Q is negative 1, 2, and R is 4, 3. After knowing that, we can now come and find, for example, the first one, which is the length of P. This is simply finding the root of x squared plus y squared. So what is our value of x in this case will be 3 squared plus y squared. Our value of y is 1. But all of it must be under a root. So we shall continue. 3 squared is 9. And 1 squared is 1. And a root. When you add 9 plus 1, you'll be in position to get 10. And a root. So simply we are saying our value for length of length P is 10, but under root units. Let's find the next one, which is the length of P plus Q. That is P plus Q. We are finding its length. So this is the same as adding the value of P and Q, and that is 3, 1 plus negative 1, 2. These are the two values. For a number given like this, first thing you need to get value of P plus Q. After getting the value, that's when you go on to find the length. So in this case, we are going to add, it will be 3 plus negative 1, 1 plus 2. When you continue with this, we shall have, this is a negative, 3 minus 1 to give you 2, 1 plus 2 to give you 3. So this is where we shall start finding the length for PQ. After having this, we shall now say length PQ should give us the root of x squared plus y squared. But what's your value of x in this case? X is 2 and y is 3. So we shall have 2 squared plus 3 squared and a root. So when you continue, 2 squared is the same as 4 and 3 squared is the same as 9 under a root. So with this, we are now going to say 4 plus 9 should give us root of 13 units. So finally, the magnitude of P plus Q is 13 units. So whenever given two different, for example, here we are using letters. When you are asked to add, first add and get a value for the addition, then after what you will get, like how we got 2, 3 here, is what you will use to find the length of that given number. For example, after getting the value of 2 and 2, 3, we now know that the value of x is 2 and the value of y, so it becomes simple for you to find the length. Let's have the next one, which is example C. It was telling us to find 3p minus 2q. So we should be careful with reading the questions. When the question asks you to find the magnitude, it means you must find the magnitude. But if it is plain, it means you only work out and you get the final answer. But for this case, we are finding length for all the numbers. So when given a number like this, the first thing you need to do is to get solution for the given number before you find its magnitude. So we're going to have this as 3p minus 2q. That's what we are finding. This should equal to shall have 3 into the value of p, which is 3, 1, minus 2 into the value of q, which is negative 1, 2. So we shall open the bracket. The number outside will affect what is inside the bracket independently. So we shall have 3 times 3 and 3 times 1 minus 2 times negative 1 and 2 times 2. I've left the sign outside independently. I was only using the 2. It will affect later. So 3 times 3 will give us 9. 3 times 1 will give us 3. Minus 2 times negative 1 will give you negative 2. 2 times 2 is 4. So we shall continue here and have, we now open the bracket. We shall have 9 minus minus 2 and 3 minus 4. Negative times negative will give us a positive. 9 plus 2 will give us 11. And 3 minus 4 will give us negative 1. After having this, we shall now go on to find the magnitude of 3p minus 2q. So here we're going to have 3p minus 2q, but the magnitude. To get a magnitude, we said is simply x squared plus y squared. And what is our value of x in this case? It is 11 squared plus negative 1 squared. 11 squared is 121 plus a negative squared becomes a positive, so we shall have 1 here. And finally, when you add the 2, we shall get root of 122 units. So therefore, our 3p minus 2q magnitude should give us 122 units. So that is it with finding the length, the magnitude, or the modulus of a given number. When given a question, first of all, you need to understand the question. And whenever we are asked to find the length, we need to know the formula being used. It's simply the finding a root of x squared plus y squared. So when given a number, you need to work out and know which one is the x value and which one is the y value before you find the length. Next, we are going to have geometry of vectors. Geometry of this is simply the addition of vectors. That is the movement. For example, if you have a square, we're going to have, let me draw this to help us. When we have something like this, shall have this. arrows tell us the direction being taken. This is P, 3, 4. This is Q, 6, 9. Then here it is, the origin. From the above diagram, we can see the displacement of PO. This is the origin. You started moving from O to P, but you can either move from O to P, then P to Q. Those are movements. Or you can move directly from O to Q. So the movement is in two ways. You can move with a shortcut whereby to reach Q, you need to first move from 0 point O to P. Then maybe you rest and you continue from there, or you can choose to move directly from O to Q. So from the above diagram, we can see that the displacement PQ followed by displacement OQ is the same as the displacement PQ. Let's note that down to remind us from the diagram. We can see that the displacement, PO followed by the displacement followed by the displacement OQ is the same we are saying that displacements in the movements from one point to another can be illustrated in the given diagram, and we've said that we can see that the displacement PO from PO followed by the displacement OQ is the same as the displacement PQ. This is an example. This is an example of vector addition. So with the geometry of vectors, mainly we are going to deal with addition of vectors. For example, we can write what we've all written here simply as PQ is equal to PO on displacement plus OQ. With this, the movements have to flow. For example, for you to move from P to Q, you started moving. For you to move from P to Q, you need to move PO, then OQ. But you cannot say that for you to move from P to Q, you need to move PO, QO. It will not work. The directions have to speak. Movement from P to O is on a negative direction because here our arrow is moving upwards. So it means we have to start from the origin. But if we are moving from O to P, it is a positive direction. But here we are saying PQ, which is the movement from here up to here, means you are moving PO plus OQ. So, but OP is the same this should be PO, but PO is the same as OP, but in the opposite direction. In the opposite direction. For example, when you look at this arrow is simply telling us that the movement starts from the origin towards P. But if we talk of PO, it means we are moving in the reverse direction. So PO becomes a negative of OP. That's what we are saying. But PO is the same as OP, but in the negative or the opposite direction. So we are saying PO is equal to negative OP. So now we are saying PQ is equal to negative OP plus OQ. Is the same as PQ is equal to OQ minus OP. Let's take an example. Let's say example 1. Given that OP is equal to P, and the value for that is 1317, and OQ is equal to Q, which is also equal to the value which is 5, 2. Calculate the length of PQ. So we are beginning to understand the examples of geometry vector. We said it's mainly about the addition of vectors, and in this case we are having an example which is given that OP is the same as small p, and the value is 1317, and OQ is the same as small q, and the value is 5, 2. Calculate the length of PQ. Let's have a drawing to help us interpret this movement. We're going to have this. Remember, vector is all about direction and magnitude, so we should not forget the arrows. And after that, we shall have this. Then we shall join this back to the origin. Okay. And we shall not forget our direction that tells us the movement. This will be O, the origin. Shall have here P, and the values of P are 13, 17. And inside we shall have Q, which is 5, 2. Okay, with this we are now going to find the length of PQ. PQ is this. And we said from the first example, to get the value of PQ, we need to have the movement from here up to here, then here up to there. The movements have to coordinate. It means you move from one point to the other. You cannot jump from this and you leave the other one up to the other one, but you move from one point to the other. So now we are going to have we're now going to calculate our length PQ, and we are saying our length PQ is the same as PO plus OQ. But we are saying PO is in the opposite direction. PO and OP are the same, but the difference is the movement from P to the origins in the opposite direction, which is the negative or the reverse. So to move from here up to there is a positive. It's the same answer, but the same distance, but they vary in terms of the sign. This one is a positive movement and this one is in the reverse or the opposite direction, which is bearing a negative value. So with that, we are going to say this is now negative OP plus OQ. So we can start with QO minus OP. But what are our given values? Our OQ is 5.2 and our PO is 13. So here we're going to have our QO, which is 5.2. Sorry, this should be OQ, not QO. So we shall have OQ here, and the value is 5.2 minus the OP, which is 13.17. So with this, we are going to say it is 5 minus 13. Then this is 2 minus 17. Now we are saying 5 minus 13 will give us negative 8. And 2 minus 17 will give us negative 15. So this is going to be our value for this movement. I've just wrapped the diagram. We are saying we are finding the length PQ. The movement, when you move according to the diagram we've just drawn, we are finding the longer distance PQ. So when you work out, we are saying it is PO plus OQ. But PO is on the opposite direction of movement from the origin, and the origin was the O. You move from O to P. So in this case, our value of OP will be the negative one. That's why we are saying we simply alternated and we started with the positive, which is OQ minus OP. So our values according to the question for OQ is 5.2 minus the OP, which is 13.17. We came here and opened the two brackets and we subtracted correspondingly accordingly to x's alone and y's alone, and finally our value of PQ became negative 18, negative 15. So if we are to continue and find the length of PQ, which we said it is donated by this sign, we are simply going to say to find the length, remember it is x squared plus y squared. So here we are going to just have these values, and the root we shall have negative 8 squared plus negative 15 squared. When you work this out, you will have 64 plus 225, but all of it under a root. So when we continue with this, we shall have square root of 289, which will give us 17 units. So we are saying therefore the length of PQ is the same as 17 units. This is it for the geometry vector. We said it's simply finding the total distance of the displacement moving from one point to the other. The movement can be two-way. You can use the longer route or the shorter route, whereby you will have to pass several different routes to reach your final destination. So with that, you first have to find the value of what is being asked for before you find the length. We said to get the length, you need to know the x value and the y value. You cannot know the value of the x unless you first work out everything to get single value. Then after, you'll be in position to find the length or the magnitude of a given number. So with this, we shall end here for today. Keep it education online. I remain your teacher, Madam Dani Susan.